Hey everyone, welcome to this tutorial where we'll be building a chatbot using Google Generative AI and Fast API. We'll walk through the entire process, from setting up the AI to creating a web interface and testing it locally. Whether you're a beginner or have some experience with AI and web development, this video will guide you step by step. So let's dive in and get started with our chatbot project. First, head over to asstudio.google.com. Once you're there, navigate to the section where you can manage your API keys. Look for the option that says Get API Key and click on it. This will generate your Generative AI API key, which you'll need to integrate Google Generative AI into our project. Make sure to copy and store this key securely, as we'll use it shortly in our code setup. Using pip, install Fast API and Google Generative AI by running the following commands in your terminal. Pip install Fast API. Pip install Google Generative AI. First, we start with the basics. We import Google Generative AI as GenAI and configure it by calling genai.configure and passing our API key. Next, we create a function that accepts the user's message and the previous chat history, if any. If there is a previous chat, we give the AI some modified message. We ask it to use the chat history to answer the user's question. That way we can preserve the chat context. For example, if the user previously asked about a car, then sends how much does it weigh, the AI can reply using the information about the car. If there isn't a previous chat, then we give the AI just the message. Now we can call the Generative AI's chat function. We set the model to chat bison and configure other settings. Then we pass the prompt. The Generative AI returns a list of replies named candidates, so we choose the last one using nice one and return the value of the content key, which is the reply. To test our code, let's create a while loop. Since we'll be hosting this, we don't want the local part to run when hosted, so we check if name equals main. Create a running flag for the while loop and a local history variable set to an empty string by default. You'll understand this later. At the start of the application, we greet the user. Start the while loop. Get the user message. Set the running flag to false if the user sends Q. Now we call the reply chat function with the user's message and the local history variable, which we update after the first message. We concatenate the local history with the user's message and the AI's reply in a format the AI can understand, distinguishing between the user's message and the AI's response. Then we print the reply to the screen. That's all we need to test it locally. Let's build the API. We import additional modules, annotated from typing, and a few more from Fast API. Initialize the Fast API class with a title for our AI. We'll be using some HTML with Jinja 2 to build the UI, so let's tell Fast API where to find the templates, then mount the static folder to load our images. Here we take a slightly different approach from the local code. We create two chat histories, one to send to the chatui.html as a list to display, and one to send to the AI as a string, like we did in the local code. When a GET request is made to the server, we return the chatui.html without any chat history. For POST requests, we pass the message to reply chat, add it to both histories, then return the chatui.html with the chat history. In the GET request, we declare the response class as HTML response because we'll be sending the chatui.html as the reply. We create a dict to pass as context to the HTML response. The first value is the request, then we send the empty chat history as chats. Now we return a template response and pass the HTML file name, which we'll create in a minute, and the context. We do the same thing for the POST request, except that we require the user to pass a message in the POST request as form data. We can set this by using annotated and the form class. Another thing we do here is get the reply to the message and append both the user message and the bot's reply to the histories. We create the context and return the same template response.